Hello everyone, welcome to an algebra tutorial video about factoring polynomials completely using multiple steps. So in these few examples, we're going to be taking all the different methods we have of factoring trinomials, factoring binomials, factoring different special cases, factoring with four terms, and recognizing that sometimes we have to factor one method and then look at what we have and then factor again to completely factor all the way down. So here we go. We've got 48x squared y plus 104xy minus 64y. We've got a trinomial. We've got three terms. And this thing looks incredibly complicated, right? Big numbers. What's going on? How do we get started? Well, before you really get into panic mode, the first thing you always want to do when encountering any trinomial and you want to factor it, or any polynomial for that matter, and you want to factor it down, is find step one, find the greatest common factor. Always pull that thing out. Sometimes it'll make it much easier to see what you have left. So let's look at each of these three terms and see what we have in common. Well, between 48, 104, and 64, I know those are even numbers, so I know it's a factor of 2, but if I really dig into it, they each actually have a factor of 8. 8 is a number that divides, it's the largest number that divides each one of those numbers evenly. Now let's look at my variables, x squared, x, and then no x terms. So there's no x variables in common between all three, but they do each have a y variable in common. So I'm going to factor out a y as well. All right, let's divide that out. Put my factor, my greatest common factor in the front. And now let's focus on what we have left. 48 divided by 8 is 6. X squared, and the y's are divided out, so I don't have any more y's. 104 divided by 8 is 13. I still have an x, but again the y's are divided out. It's nice. And minus 64 divided by 8 is just 8, and the y's cancel out. Alright, so we factored out the greatest common factor, and now we can look at what we have left and see if we can factor that part down anymore. Well, I've got a trinomial, 6x squared plus 13x minus 8. So with a trinomial and my coefficients, I have a coefficient for A is 6, B is 13, and C is negative 8. So I need to use all three coefficients and actually use my factoring techniques. In this case, I need to look for two numbers that multiply to A times C. So 6 times 8 is, that's negative 48. So I need two numbers that multiply to negative 48, but they also add up to 13. So let's think about my two numbers here. Got to multiply to negative 48, but yet they add to 13. So let's list out my combinations of negative 48. So 2 times 24, 3 times 16, 4 times 12, and 6 times 8. Those are all the factors of 48, or multiples of 48. And I need to find, notice they're going to multiply to make negative 48, so one of them has to be negative, the other positive, but they add up to make positive 13. The combination I want is going to be that one right there, negative 3 and positive 16. Those multiply out to make negative 48, and they add to make 13. What does that do? Again, you can review our video where we really went over this factoring technique of factoring any trinomial, but it lets us rewrite 6x squared plus 13x minus 8 as four terms. So let's do that. We've got 6x squared. Now instead of 13x, we've got plus negative 3x plus 16x. There's my two numbers that I found, so I can rewrite 13x as those two numbers, and then minus 8. And because I don't want to forget it, I still got my 8y in the front. It's all multiplying all of that. Okay, now let's factor by grouping. Let's split this thing up. So I've got two groups, one group there, one group there, and let's factor out the greatest common factor from each group. From 6x squared and negative 3x, I can factor out a 3 and an x. So that gives me 3x times, what's left is 2x and minus 1. Plus, now what's in common with this other one here? So between 16x and 8, I'm going to pull out an 8 from each one of those. The 8 goes in the front, and I am left with 16 divided by 8 is 2. There's still the x, and 8 divided by 8 is 1. All right, we still got my 8 times y in front of all that. But there's my common binomial factors that make me feel really good that our factoring by grouping method is going to work. So we factored those out in front, and we've got 2x minus 1 times the 3x plus 8. And all of that was still multiplied by 8 times y. Okay, I am feeling pretty good about factoring that thing all down. We have 8y times 2x minus 1. I can't factor that any further. Times 3x plus 8. I can't factor that any further. So all this original trinomial we had is equivalent to this factored form right down here. We factored in to do a monomial and two binomials multiplied. All right, hopefully that's helpful. Again, what did we do? We did the greatest common factor first, and then we took a look at what was left, and it was just a trinomial with coefficients for a, b, and c. So we used our factoring trinomial method. We looked at a times c and b, found our two numbers, broke it into 4 terms, and then factoring by grouping. So we had to use 2 methods on this one, 3 if you consider factoring by grouping and finding our two numbers as 2 separate stages. But hopefully this is helpful for you to realize we can factor polynomials in multiple steps and the importance of doing the greatest common factor first.